Good morning, ladies and gentlemen. This is a video that is going to explain how to balance chemical equations, proving the law of conservation of mass, using a virtual PhET lab. The first half of the lab I'm going to do with you as a class. The second half of the lab you're going to do on your own. Just a reminder, we do have our chemistry exam tomorrow, and this material will be covered on the exam. Let's get right to work. When you do this lab on your own, you're going to need to get to my Schoology page. On my Schoology page, under Unit 1 Chemistry, you'll see the Balancing Chemical Reactions PhET. That's what we're working on today. This is the link to the PhET. This is the worksheet page you have to do. If you don't have the worksheet page, the teacher does have some extras. This is the page that you need, and this is where the link for the PhET will take you. Please, I'm going to hit pause right now. Take a couple of seconds to get this page out and to get a writing utensil. Pause. And we're back. We've all got this page out. That's excellent. I'm going to go here, and I'm going to go to Introduction. The first question on your worksheet asks, explore the balancing chemical equation simulation. What are the different ways this simulation indicated that an equation is balanced? Talk to your neighbor if necessary. You don't need to talk to your neighbor. We're going to do it right here in class. Number one, the first way we can figure this out is by using the tools. Either the scales, which I don't like, or the bar graphs, which I do like. Okay? So, number one, you can use the scales or the bar graphs. Another way you could do this is simply by counting the atoms in the white boxes. So for question number one, how do we know that the equation is balanced? The answer is using the scales or the bar graphs under tools, or by counting the actual atoms in the white boxes. I'm going to hit pause so you can write that down. Pause. And we're back. Now we can get to work on actually balancing some of these chemical equations. The first reaction we're going to do is we're going to make ammonia. Ammonia is found in Windex. Ammonia is NH3. It's made up of nitrogen gas and hydrogen gas. These are your reactants. Nitrogen and hydrogen are your reactants. Ammonia is the product. This is the process it goes through. The first thing we need to do on any of these problems is to make all of the coefficients at least 1. This program's great because it automatically does the atomic inventory for you. Right now we've got 2 nitrogens and 2 hydrogens on the reactant side, and we've got 1 nitrogen and 3 hydrogens on the product side. Even though the total number of atoms on each side is both 4, this isn't good enough. We need to make sure that the nitrogens on each side are the same, and the hydrogens on each side are the same. So in order to go from 1 nitrogen to 2 nitrogens, I can change the coefficients. I can't change the subscripts, but I can change the coefficients. If I make this a 2, now I have 2 nitrogens. But now I have 6 hydrogens. I only have 2 over here. I can change my coefficients over here. I don't need to touch the nitrogen. My nitrogens are good. 2 and 2. I do need to change the hydrogens. What can I do for a coefficient to make this 6 total hydrogen atoms? Make that a 3. Smiley face, we're good. 2 nitrogens on each side, check. 6 hydrogens on each side, check. The chemical formula is 1 part nitrogen plus 3 parts hydrogen will give you 2 parts methane. That's the recipe. The recipe is important because if you don't have the exact right ratios and amounts, it's not going to work. If, for example, I had 2 parts hydrogen, it doesn't work. If I had 2 parts nitrogen, it doesn't work. It must be 1 part nitrogen, 3 parts hydrogen, and 2 methanes come out of that. Notice we are changing nitrogen gas and hydrogen gas into methane liquid, but the amount of mass is exactly the same. If I went to the scales are balanced. When I go to the bar graph, the bars are equal. Now what I need you to do is I'm going to hit pause. You need to count the total number of atoms on the reactant side and on the product side and fill that in. How many total atoms are on this side and how many total atoms are on this side? Pause. And we're back. I'll reset this out. And we're moving on to number 2. All right? Number 2 is separating water. Again, here are your reactants. We're going to react the water, in this case with a little electricity, and our products are going to be hydrogen gas and oxygen gas. Step 1, make them all 1. Atomic inventory is already done for us. Looks like the hydrogens, the white dots, are good, 2 and 2. Looks like the orange dots, the oxygens, are not good, 1 and 2. All right? Looks like I need 2 oxygens on this side to match the 2 oxygens on the products. All right? Turn the coefficient into a 2. I can double my amount of water. I can't change my subscripts, but I can change my coefficients. Now we've got 2 oxygens here and 2 oxygens here, but we have 4 hydrogens here and only 2. We got to figure what we're going to do. I don't want to touch the oxygens. They're good, so I've got to do something to these hydrogens. Smiley face. We are good. 4 hydrogens on this side, 4 hydrogens on this side, 2 oxygens on this side, 2 oxygens on this side. We electrocute liquid water. We get hydrogen gas and oxygen gas. How many total atoms for the second part of number 2 are on each side? How many total atoms? Either add or count. I'm going to hit pause. And we're back. 1 more to go. Combusting methane. Methane plus oxygen to burn it gives you carbon dioxide gas and water. Unfortunately, this happens in power plants. And this carbon dioxide gas is a greenhouse gas. And we need less greenhouse gases in our environment, not more. Step 1, make all of these 1. Atomic inventory is already done. Looks like on the reactant side, we've got 1 carbon, 4 hydrogen, 2 oxygens. And on the product side, we have 1 carbon, 2 hydrogens, and 3 oxygens. Carbons are balanced. Hydrogens, oxygens are not. All right. I like to start with the hydrogens because 2 and 4, they easily can go into each other. All I have to do is double my hydrogens over here. I won't touch these guys. There's no hydrogens there. I'll touch the waters. There's hydrogens there. If I double those, I have 4 hydrogens and 4 hydrogens. Good. I still have 1 carbon and 1 carbon. Good. But my oxygens are not balanced. See? I got 2 oxygens on the reactants and 4 on the products. Looks like all I got to do is double the oxygen. Smiley face. 1 carbon, 4 hydrogens, and 4 oxygens are on each side. I'm going to hit pause so you can fill out this last row. How many total number of atoms are in the combustion of methane on each side? Pause. And we're back. You should have number 1 taken care of, and you should have this whole chart taken care of. Let's do number 3. Is the total number of atoms on the left side equal to the total number of atoms on the right side if the equation is balanced? That's easy. Yes. right? The answer is yes. Those numbers should be the same on both sides of that graph. Data table. Number 4. What is always the same on the left and right side of a balanced equation? Well, one thing that is always the same is the total number of atoms. Total number of atoms should always be the same on both sides in a balanced equation. The other thing that should be the same the number of the type of atoms. In other words, the number of N's should be the same on both sides. The number of H's should be the same on both sides. And the number of oxygens, for example, should be the same on both sides. So not only do the total number of atoms have to be the same, the specific type of atoms have to be the same as well. And that's number 4. I'm going to hit pause so you can write that down. Pause. And we're back. The last part of your lesson is on your own. Either on your phone, or we have computers for you to use. Play level 1 of the balancing equations game. How do you get to level 1? Click game, level 1. I want you to get 5 stars. Number 6, start level 2. Use your strategies from level 1 and add down new strategies. Write down the equations on a separate sheet of paper as you solve them. Here's the thing. You don't need to write those down. Go here and go to level 2. I want to see 5 stars. Number 7, in the simulation, were you able to use non-integer numbers? So answer 7a and 7b. Finally, answer 8, Roman numeral 1, Roman numeral 2. On this worksheet, you're only going to do this first page here. Make sure your name is on it, and you're going to turn it in to the substitute teacher before you leave for the day. If you finish early, I strongly suggest giving level 3 a try. These will be on the exam tomorrow. Maybe not these specific reactions, but you will have to know how to do this. The more practice you can get, the better. Your teacher will be there for you the rest of the day. If you've got any questions, please ask. But let's do our work to the best of our ability. Let's make sure we ask good questions if we need to. And we're going to be super respectful and super awesome for our guest teacher. Have a wonderful rest of your day.